All right. So at first glance, this might look like an identical video to the one that I have done previously, where we're calculating the arithmetic mode. Um, but how this is different from the previous instruction is that we're calculating the arithmetic mode, that's true, of continuous data. But now we're looking at what is called an ill-defined mode. It's an ill-defined mode because we have two modal classes. So this one and this one, because they both have the same frequency, but they are non-adjacent. Okay. Non-adjacent meaning they don't share a boundary. Instead, there's this class of 23 with a frequency of 23 in between them. Okay. Um, so there's two things going on. One, there are two modes, and they are non-adjacent. Okay, that's one thing. The other thing that's going on here is this distribution is skewed. And what I mean by skewed is it seems to be shifted to one side. So it kind of looks like all of the data is sloping over to the left, to the lower values. Okay. It could be skewed in the other direction. It could look something like this. That would also be skewed. Um, you can use this formula in an ill-defined skewed distribution, okay, with ill-defined modes and the distribution is skewed. You would not be able to use this if the distribution looked symmetrical. So if it looked something like that. So if you had maybe two modes that were non-adjacent, something like this, um, you would not be able to use it in this case because this looks like a symmetrical distribution. It's not skewed like this or skewed like that. Okay. So that's what I mean by that the distribution is skewed, meaning it's shifted to one side. All right. So what's that formula, and how do you use it? Well, the formula is actually simpler than all the others. The arithmetic mode, when you've got an ill-defined mode and the distribution is skewed, is going to be 3 times the median minus 2 times the mean. That's it. So if you have access to the data set, then spreadsheet software can calculate the median and the mean directly. So the spreadsheet software can give you this number and it can give you this number. And you just multiply the median times 3 and subtract the product of 2 times the mean, and you've got your arithmetic mode. But in this case, when you're not given the data and you're working from a distribution table or a histogram, then you have to calculate the arithmetic median and the arithmetic mean using the previous examples that I gave. Um, so, to kind of refresh your memory, the arithmetic mean uses this equation, and the arithmetic median uses this equation here. So if we used, this first equation to calculate the arithmetic mean of this distribution up above, again, you can do your own work to confirm this, but this is the value that you should get, 438.3125. And if you use the equation for the arithmetic median, you should get 431 exactly. And so to calculate the arithmetic mode, It's just 3 times the arithmetic median minus 2 times the arithmetic mean. The arithmetic median was 431, and the arithmetic mean was 438.3125. And so 3 times 431 minus 2 times 438.3125 gives you an arithmetic mode of 416.375. So, this equation is significantly simpler than the other ones that you've used, but you may need to use the previous two equations to get to the point where you can use this one. All right. So if you want some practice, again, for doing this type of problem, you want to be able to master this skill. Again, I've got a link here to a MyOpenMath problem that you can click on, and it'll open up a MyOpenMath problem in your web browser, and you can check your answers, you can get new questions, and just keep doing it until you feel comfortable doing this type of problem. All right. Let me know if you have any questions.